Hey class, so today's lesson is on scientific notation. As the name suggests, this will be something you will have to use in your science classes, maybe this year, but if not, then definitely in the next few years. So let's get to it. We're going to start scientific notation by reviewing multiplying by 10. Okay, so if I have a number, any number, I'll just make something up, 23, Michael Jordan. Okay, that's a number. And if I want to multiply that by 10, there is a trick or a shortcut, if you will, on how to get the answer. And that is to add a 0 to the end of it. So that would be 230. Okay, so to multiply by 10, you can add a 0 as a shortcut to get the answer. Similarly, we can multiply by 100, and the shortcut for multiplying by 100 is actually adding 2 zeros, so 2,300. And you can think of it as applying multiplying by 10 shortcut twice. Okay, you can think of it multiplying by 100 as multiplying by 10 twice, because 100 is equal to 10 times 10. So really, you're taking the number 23 and you're multiplying it by 10, so you add a 0, and you multiply it by 10 again, so you add a second 0. So the shortcut is to add 2 zeros. Now, what's another way to express 10 times 10? Well, that would be 10 squared. So in other words, if you are multiplying by 10 squared, you're adding 2 zeros. Okay, and we can continue the pattern indefinitely. So if I want to multiply by 1,000, you may know that 1,000 equals to 10 times 10 times 10. Okay, it equals to 10 times 10 times 10. Or another way to express 10 times 10 times 10 is 10 cubed. So 23 multiplied by 1,000, you can use the multiplying by 10 shortcut 3 times. That is to say, you can put 3 zeros at the end of it. Okay, and that works for any power of 10. We call them power of 10s. So I can skip a few, and maybe I'll have 23 times a million. A million has 6 zeros to it. And we can go through all of that thought process again, but we're going to add a shortcut to the shortcut. So how many zeros am I going to have to add to 23 to get the answer? Well, the shortcut to that is to actually count how many zeros you have here. So the number 1 million has 6 zeros. So 23 times a million will be 2, 3, and then 6 zeros. So 23 million. So you can count the number of zeros in that power of 10 to know how many zeros you need to add. What's another way to express 1 million? Well, you can actually express it as 10 times 10 times 10 times 10 times 10 times 10. Because there are 6 zeros in a million, it's actually the number 10 multiplied by itself, like 6 copies of it multiplied by itself. So we can express that as 10 to the exponent of 6. So these tens, so 10, 10 squared, 10 cubed, 10 to the 6, we call these powers of 10. And the shortcut for multiplying by a power of 10 is to add that many zeros. That is only if the number you started with, in this case we used 23, is an integer. What if the number you're starting with has a decimal? Let's say 6.02, for example. 6.02, just a random number. And let's ask what happens if I multiply this by 10. Now, I'll tell you what's not the answer. The answer is not simply putting a 0 after the 2. This is wrong. So I guess adding a 0 at the end, that shortcut only works if you started with an integer. But if you're starting with a decimal number, we have to do something different. The shortcut, if we're starting with a decimal number, is to actually slide the decimal place over one spot towards the right. One spot towards the right. That is the shortcut for multiplying a decimal number by 10. So the answer would be 60.2. So the shortcut is to slide the decimal to the right one spot. Okay. Now, if you are going to multiply by 100 now, so 6.02 times 100, as we said on the previous slide, 100 is the same as 10 times 10. So we just have to apply the shortcut twice. We just have to apply that shortcut twice. So that is to say we're going to take the decimal point and slide it over 2 spots. 1, 2. And the decimal is going to end right after the digit 2. So the answer will be 602. And we don't have to put the decimal point at the end of the 2 because there's nothing after it. 602 is just going to be a whole number. So I'm just going to leave it as 602. Okay, so what is another way to write 100 again? Another way to write 100 is 10 squared, 10 times 10. Okay, so if you are multiplying a number by 10 squared, you will slide the decimal place over 2 times. And what about if you're multiplying by 1,000? Or what's another way to say 1,000 again? It's 10 times 10 times 10, so that's 10 cubed. And if we follow the pattern, this means we have to apply the sliding the decimal spot over 3 times because we're multiplying by 10 3 times. Now that's kind of strange because it looks like there's only 2 spots to slide it. 1, 2. So how do we slide it that third time? Well, now is when you actually go back to the previous slide. If you've run out of decimal place, like decimal spots to slide it, then you start adding zeros again. Okay, so I've only been able to slide it twice, but I need a third time. So that third time will look like adding a 0. So the answer is going to be actually 6020, 6020. In general, okay, so in general, when multiplying by a positive integer power of 10, slide the decimal and or so slide the decimal to the right and or add a 0 on the end for each for the number of times equal to the exponent. So whatever the exponent is on the power of 10, we will slide the decimal point over or add zeros until we reach that number. So I'll give another example. I'll make up another number. Okay, let's make up another example here. Different number, I'll say 4.567, just a random number, and we'll multiply it by 10 to the exponent of 5. Okay, that's what I'll go with. So if I follow the general rule, I am multiplying by a power of 10. So that means I will slide my decimal point to the right 5 times. But I can only do it 3 times until I reach the end. 1, 2, 3. So how do I get to 5? Well, that's when you start adding zeros. So I have to add 2 zeros. Okay, 4, 5. So that's 5 places overall. The answer is going to equal 4, 5, 6, 7, 0, 0. Okay, so that is multiplying by a positive integer power of 10. Now, we are going to multiply by negative integer powers of 10. For example, let's take the number I'll say 35. What if I have to multiply it by 10 to the exponent negative 1? We will start with 10 to the exponent negative 1. So you actually have to go back to the previous lesson and remember what negative exponents means. So 10 to the exponent negative 1 means the reciprocal of 10, which is 1/10. Okay, so that's from lesson 4, 10 to the exponent negative 1. You should recognize that as 1/10. So now it's 35 times 1/10, which you should recognize as 35 divided by 10. Or, let me write it a bit better, a different way. Write it as a fraction. 35 over 10, which is 35 divided by 10. So in other words, what I'm trying to say is when you're multiplying by a negative integer power of 10, you're really actually dividing by a power of 10. Okay, so multiplying by a negative integer power of 10 is the same as dividing by a power of 10. So now let's talk about shortcuts for dividing by 10. So here we have 35 divided by 10. How do you do 35 divided by 10? The shortcut for dividing by 10 is actually similar to the shortcut for multiplying by 10. We will move a decimal point over, but in the other direction. So that will mean left. So shortcut to divide by 10 is to move the decimal, I'll say slide, I like slide better, to the left one spot. Okay, so you have to know when to slide right and when to slide left. When we are dividing by 10, we slide left. So if we take the number 35, where is the decimal point? Well, that's a whole number, so the decimal point is right after the digit 5. And the shortcut says to slide that decimal one spot to the left. So it's going to end up in between the 3 and the 5. So the answer is going to be 3.5. That is how you divide, or sorry, that is how you multiply by 10 to the exponent negative 1. We'll try another one. So I'll start with a decimal number this time. I'll say 42.38. And if I want to multiply by 10 to the exponent negative 1, if I follow the shortcut, you slide the decimal point over one spot to the left. Okay, so that is what I'm trying to say. Slide it one spot to the left. It will become 4.238. Another example, you can have a number starting like 0.003 times 10 to the negative 1. So if we follow that shortcut again, slide the decimal point over one spot to the left. So now we equal 0.0003. That is the correct answer. Sometimes mathematicians don't like reading numbers like that, so they will put an extra zero before the decimal point. Does not change the number itself, but it makes it easier to read. Okay, so that's multiplying by 10 to the negative 1. What about multiplying by 10 to the negative 2? So if we, let's say, have 45.2, and we'll say multiply by 10 to the negative 2. Well, it turns out that we just have to apply the shortcut we just did, but twice. Okay, so the shortcut was for when the exponent was negative 1, but if the exponent's negative 2, we apply it twice. That means sliding the decimal point over two spots, 1, 2. So the answer will equal 0.452, and we're going to throw a 0 in front just to make it easier to read. And if we have to multiply by 10 to the exponent negative 3, we apply the shortcut 3 times. So we're going to slide it over 3 spots. 1, 2. Oh, it looks like we have run out of spots to slide it over. How do we slide it over that third spot? Well, here's where we start adding zeros again. But this time the zeros are going to be on the left side. Okay, so you have to add the extra 0 there. So the answer is going to be 0.0452. That's not nice to read, and we'd often throw that 0 in front of the decimal to make it easier to read. Okay, let's skip a few. We can have 45.2 times 10 to the exponent negative 6. And in this case, we would slide the decimal to the left 6 times. So let's count. 1, 2, and I need to go 4 more times. So that will actually involve writing 4 more zeros on the left side. 1, 2, 3, 4. That gets it 6 spots over. So the answer will be 0.000452. And if that's not nice to read, we put a 0 in front of there. Okay, so that is multiplying by a negative integer power of 10. So now we have done both. Just as a review of one thing from the previous lesson as well, what if I asked you to multiply by 10 to the exponent of 0? Okay, we did positive powers of 10, we did negative powers of 10. What if I ask you to multiply by 10 to the exponent of 0? Well, so I'm seeing if you remember last lesson that anything to the exponent of 0 equals to 1. So this is really just saying 45.2 times 1. And anything times 1 is itself. So the answer is just 45.2. Okay, so that was just, I really want you to remember what something to the exponent of 0 equals to. Okay, so all of that was actually background knowledge for this thing called scientific notation, the title of the actual lesson. which you're going to see in science class. We don't really do too much of it for the rest of math class. Okay, scientific notation. So I'll say in science, which I get to teach a lot of, numbers are often expressed in scientific notation which means they are expressed, or they are, expressed as number I'll say from 1 to 10 multiplied by a power of 10. So that is probably strange sounding. It's going to take a while to absorb what that really means, and it's going to speed up the process by doing examples. So in science, you have a very, very, very large number. Let's say the distance between the Earth and the Sun. I'm not sure how much that is actually. I knew it once upon a time. Okay, let's just pretend whatever this distance represents, 150 million kilometers. Okay, that I don't think I got it right. I don't think that's the actual distance between the Earth and the Sun, but something is going to be that far. We have this humongous distance, 150 million kilometers. Scientists will often condense that, use less space on the page, I guess, not write all these humongous numbers by using scientific notation. So that means to rewrite it as a number from 1 to 10, but then multiplied by a power of 10. So the number that you write down, so I'm going to say equals, the number I'm going to write here on the right side, it has to actually equal the number on the left side. I'm not changing the number, okay? That is a very important point. I'm not changing the number. I'm just writing it in a way that looks different, in a way that uses exponents. So one key of this definition is that it actually needs to start with a number from 1 to 10. It needs to start with the number from 1 to 10. So the steps I would suggest, step 1, place a decimal point after the first non-zero digit. Place a decimal point next after the first non-zero digit. So on this question, 150 million, the first non-zero digit is 1. So I'm going to place a decimal point there. See, I'm color coordinated here. I did that in green because step 1 is in green. And now step 2, count how many places and in what direction you must slide the decimal point to get the original number back. Okay, so it says count how many places and in what direction you must slide the decimal point to get the original number back. So where I put that green decimal point, that was step one. I need to get my original number back. So I'm gonna have to slide it 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm gonna have to slide it 8 spots to the right. So now I think back to my kind of shortcuts for multiplying by powers of 10. If I am sliding something, a decimal point, 8 spots to the right, I am actually multiplying by 10 to the exponent positive 8. So going towards the right is a positive power of 10. So the number I'm going to write is 1.5 times 10 to the exponent of 8 kilometers. Don't forget the units. I've been taking half marks off for people forgetting units. So this is called scientific notation. When you take a number and you make it look like a number from 1 to 10 multiplied by some power of 10. What I have on the left side, 150 million, is exactly equal to 1.5 times 10 to the 8. I did not change the value of the number, just make it look a little bit different. Okay. So steps 1 and 2 are kind of the thought process. There's still a step 3, which is to put it all together and write the final answer out. Actually having trouble thinking of the words to express that. So I think I'm just going to leave it alone, and hopefully you can just learn through examples. We'll do a few more. So all of these will say express in scientific notation. Okay, first one. Let's say 3,750. And we'll say pounds, something pretty heavy. Okay, I will express that in scientific notation. So step 1 is to put a decimal point after the first non-zero digit. So I'm going to put a decimal point after the 3. And then I'm going to count how many spots and what direction I have to slide it to get the original number back. 1, 2, 3 spots to the right to get the original number back. So the answer, since I slid it 3 spots to the right, that is done by doing times 10 to the power of positive 3. And the number I write in front of the multiplication symbol is 3.750. Basically, yeah, I write the number after I've put the decimal point in, and then I write multiplied by whatever the power of 10 is. Now I don't need to write that last 0 in there because it doesn't change the value of the number. So I'm just going to write it as 3.75 times 10 to the exponent 3. Okay, that's how you do scientific notation. Let's do some more. I'm going to try the other way. This is something very, very small. So this is read as 0.000000550 meters. That's actually the length of something that we call the wavelength of light, of green light, actually. So light waves are very, very small, and this is kind of a typical distance that you'll see, very, very small. Scientists don't like to write all those digits all the time, so they use scientific notation. So step 1, put a decimal point after the first non-zero digit. So that would be after the first 5 here, do it in green. Put a decimal point after the first non-zero digit. Then count how many places and in what direction you have to slide the decimal to get the original number back. This time, we have to slide to the left. Well, we have to get back to the original decimal point. 2, 3, 4, 5, 6, 7. Okay, we had to go 7 places to the left to get back to the original decimal point. So sliding the decimal point 7 places to the left is done by multiplying by 10 to the exponent negative 7. Okay, so 10 to the exponent negative 7. Now what do we write before the multiplication sign? We are going to write a number between 1 and 10. Okay, a number between 1 and 10. In this case, it's 5.5. 5.5. You write the number basically like where you put that decimal point, and you'll get a number between 1 and 10. Those are the rules. We'll do another one of those for practice. You might even want to pause the video before I say the answer and try the answer yourself. See if you get the same thing. 0.00371. I would have lost half marks on parts A and B because it didn't put the units down. Okay, part C, we'll just say it has no units. I'm going to want scientific notation. So step 1, put the decimal point after the first non-zero digit. So in this case, put it right after the 3. And then count which direction and how many spots I have to go to get back to my original number. So I had to find my original decimal back by going 3 spaces to the left. 3 spaces to the left. 3 spaces to the left is times 10 to the negative 3. Remember, left powers are negative, left is negative powers, right is positive powers. And then the number that we're going to put in front of the multiply is a number between 1 and 10. In this case, it is 3.71. It's basically wherever you put that decimal. And that is how you express numbers in scientific notation. Oftentimes, we have to combine it with rounding. Oftentimes, we have to combine it with a rounding. So to round a number, if it asks you to round it to a certain place value, what you actually have to do is look at the digit after that and see if it's 5 or higher, then you have to round up. And if it's 4 or lower, then you round down. So for example, express in scientific notation. And round to 2 digits. So that's a funny thing. I don't know if you've ever heard it said like that before, but we say it kind of a lot in science, around to a certain number of digits. So for example, let's say 1,756. Perhaps that's how many students we have at Maxwell Heights. It's changing every day though. So it says to express that in scientific notation and round it to 2 digits. So round to 2 digits, like what does that even mean? Like this is a 4-digit number. How can we round it to 2 digits? Well, we can if we use scientific notation. So let's follow the process of scientific notation first, and that is to put a decimal point after the first non-zero number, so right after the 1, and then to count how many times we have to slide the decimal over. So in this case, it's 1, 2, 3 to get our original number back. And which way did we go? We had to slide it to the right. So if we slide it to the right, we multiply it by a positive power of 10. So we multiply it by 10 to the exponent positive 3. And the number we're supposed to put in front of the multiplication sign. So normally, like in the previous couple of slides, we would put 1.756. However, now the question is asking us to round it to 2 digits. Okay, so it's asking us to round it to 2 digits. So what you do is you write down you look at where the 2 digits are, in this case 1.7. Now you have to look at the digit after the 7, only the digit after the 7, and that digit is 5. So if it's 5 or higher, we have to round up. So that means that 1.7 rounds to 1.8. That's rounding up. We add 1, basically. 7 goes to 8. So this would be the answer. This is in scientific notation, and it's been rounded to 2 digits. Let's do another one. Let's say we have, we'll go with 0.003849. Okay, that's a second example. So I'll follow the process. Start by putting a decimal after the first non-zero digit. So in this case, after the 3. Slide it and count how many times you slide it to get the original number back. So this time I have to slide left to get back to the original decimal location. And I counted 3 spaces. So that means it's going to be times 10 to the negative 3. Now, normally the number I would write before the multiplying is 3.849. But this question is asking me to round it to 2 digits. So I look at my 2 digits, which is 3.8. What digit is after the 8? It's a 4. If the number is 4 or lower, we round down. So to round down means we keep the numbers the same, 3.8. We do not drop down to 3.7. Okay, don't make that mistake. We go down just to 3.8. And I chose this number, I chose the 4 deliberately, and I chose the 9 after it deliberately, because some people think, okay, so this 9 would make the 4 round up to a 5, and then the 5 would make the 8 round up to the 9. No, we don't do that. We don't look at 2 digits after. We only look at 1 digit after. Only this 4 here matters. And since it's 4, we round down. So that would be the answer. Okay, so the homework is going to be to take numbers, write them in scientific notation, or vice versa. You might start with scientific notation and have to expand it out to write the long version of the number. And sometimes we'll ask you to round it as well. Okay, thanks for watching.